If you clean electronic assemblies, odds are at one point in time or another, you've had to look at one of these SIR plots and make a decision about how good your cleaning process is. Stick around, because today we're going to be talking about what SIR is, how it works, and most importantly, how to interpret them so you get the most out of your data. SIR, or surface insulation resistance, is a method for us to determine how clean our circuit assemblies are. It's called out in IPC standards as a method for us to provide objective evidence needed to qualify a cleaning process. For most people, that process looks something like this. The first thing you need to do is to design the process. This includes everything from board design to selecting your cleaning parameters, things like temperature, chemistry concentration, and so forth. The next thing you need to do is to qualify that process to prove to your customer that that process is capable of producing clean boards. One way to do that is to carry out SIR measurements on coupons that you've run through your process. If the SIR shows passing results, then you're good to go. It's slightly more complicated than that because you'll also want to simultaneously run other tests, something like rows, to provide process control methods, but that's a topic for another video. So, how does SIR work? Well, the first thing that you're going to need to do is you're going to need to start with an SIR coupon board that represents your assembly. For example, this board has some QFNs, a BGA, a QFP, and a bank of capacitors. But your board might look different depending on your product. Underneath these components, we place the SIR cone pattern, which is a series of interdigitated traces that go underneath the component. The idea is that if we measure the electrical resistance across that pattern, any presence of ionic contamination will cause that resistance to drop. Now, we've agreed as an industry that a passing SIR value is 10 to the 8th ohms, or 100 mega ohms. Anything that tests higher than that after the 24-hour test mark is considered a pass. However, any dips below that mark can indicate the presence of ionic contamination, which would signify a failure. Alright, now let's look at some SIR plots. This is what you want it to look like. Notice how we have a nice, steady line above the log 8 ohm marks. This, on the other hand, would be considered a failure. The measurements are very sporadic and end up well below the log 8 ohm limit. Now, SIR failures can be caused by multiple issues. First and foremost, a dirty board. Flux residues that are on the surface can absorb water from the atmosphere, leading to condensation and subsequent electrochemical migration, which leads to failure. If that happens, you might need to reevaluate your cleaning process. The first thing you can do is to focus on those failing components. Shear them off and take a look. See if you can see any residues underneath them. This can significantly help you to adjust your cleaning process to make sure that you have success. Alright, if you like that content, make sure to hit the like button and subscribe. You can also click the bell icon to be notified of future videos. Also, if you have any questions about SIR or how to interpret the data, please feel free to leave a comment below, or you can send an email to AskDrAdam@KYZEN.com. Thanks again, and stay clean.